Welcome to Mr. Chalk's Revision Tips. In this video, we will look at metals form giant structures in which electrons in and outer shell of the metal can move away from it. So they become delocalized. So in metals, the electrons leave the outer shells, forming positive metal ions. Metals are solid at room temperature, so the structure of a solid metal consists of closely packed ions, and these ions are arranged in a regular way to form a metallic lattice, so the lattice has layers of metal ions. So most elements in the periodic table of metals, they have certain properties. So when a metal melts or boils, this change in physical state requires energy. So the energy is needed to overcome the forces of attraction between metal ions and the delocalized electrons in the metal is what we need to think about when melting them. So the more energy needed, the higher the melting or boiling point of the metal. As metals are giant lattice structures, the number of electrostatic forces to be broken are extremely large. So metals have a high melting and boiling point. The structure of metals consists of layers of metal ions. So these layers can slide over each other when a force is applied. So metal can be shaped or is referred to as being malleable. So substances conduct electricity because they contain charged particles that are able to move. So when a voltage is applied to a metal, the delocalized electrons travel through the lattice structure. So pure metals can be referred to as soft. So in a pure metal, the force needed to make the layers slide over each other is relatively small. So metals are described as malleable. So this is because of the availability of the atoms to roll over each other into new positions without breaking the metallic bond. So transposition metals are what we usually think of when we think of metals. They are hard and shiny and strong and easy to shape, so this includes things like gold, nickel, chrome, etc. So an alloy is a mixture of two or more elements where at least one element is a metal. So many pure metals are too soft for many uses, so they need to be made harder by adding another element to the pure metal, so forming an alloy. So this explains why an alloy is often has more uses than the pure elements itself. So pure iron, for example, is very soft. So adding a small amount of tungsten to iron makes tool steel, which is a lot harder. So steels are examples of alloys. In a solid state, a pure metal has a giant metallic structure. The atoms are arranged in layers, so they can go and slide over each other when a force is applied. So in a pure metal, the force needed to make them slide over each other is relatively small. However, in an alloy, there are atoms of different sizes, so the smaller or bigger atoms distort the layers of the atoms in the pure metal. This means that a greater force is required for the layers to slide over each other. So the alloy is harder and stronger than the pure metal. So if we think about what is meant by an alloy, it's just a mixture of metals. So what are the physical properties of brass different from the physical properties of pure copper? It's because brass is a mixture. Brass actually contains zinc, which changes the structure of it, so the copper metal ions can no longer slide over each other.
Thanks for watching.